All right, welcome everybody. Today we're going to go ahead and do a second day of section 5.3. So we're again going to be focusing on graphing those square and cube root functions. We're going to start by doing some review of just making sure we really do understand how to write the equations using the transformations, how to use interval notation for domain and range, and then ultimately where we're going to end is making sure that we could create these graphs from scratch by hand if we did not have access to a graphing utility. Before we go ahead and do that, we're actually going to go ahead and just take a quick look at the back page. What I have for you on the back page here is, again, I have for you the parent function graphs. I have the square root function for you on the left side, and then I have the cube root function for you on the right side. Remember, of course, that the square root function just looks like half a scoop starting at the point 0, 0, where the cube root function kind of has a scoop in both directions, with 0, 0 kind of being the most important point because it's where the two pieces meet. Then consider the domain and the range. Remember that the domain is always the x values left to right, where the range is always the y values bottom to top. As a reminder, the cube root is the easy one, where all real numbers all the time for domain and range. And of course, you're going to do that from negative infinity to infinity. Then over here for the square root, remember that those have a domain and range that depend on where 0, 0 goes. And you're going to start with a domain of x is greater than or equal to 0, which would be 0 to infinity, and a range of 0 to infinity as well. I also want to remind you about those parent function tables. And again, everything I'm writing here, you should write, because when we come back to the backside, we're going to need this information. So again, the table that we're going to use as the guideline for our radical functions, our square root functions, are 0, 0, 1, 1, 4, 2, and 9, 3. That is how we get all the points on the right-hand side of the scoop, even if you only see a couple there. And then remember, for the cube root table, it's a little different because you can take the cube roots of negatives. So -8, -1, 0, 1, and 8. And then they have cube roots of -2, -1, 0, 1, and 2, respectively. Remember, you could choose additional x values as needed, including ones that give you decimals. But obviously, we're trying to make things as easy on ourselves as possible. Now that we've kind of refreshed ourselves about what the pictures look like, what the tables look like, and what the domain and range look like, let's go ahead back to the front side. And you're going to have a chance in a minute to pause and try it just to make sure that the stuff from yesterday really has hit home before we go ahead and dive a little deeper. So in the first four problems, these are each a square root function. You're going to write the equation and give the domain and range in interval notation. Just like yesterday, you're going to assume that there is no stretch or shrink. Remember, those are pretty hard to tell from a picture. And the first one is already done for you. So again, if I'm looking at the graph here of the square root function, I want to identify where the end point is, where the start point is. You can assume that everything has a scale of 1, unless otherwise noted. So compared to the original parent function, which again, we just saw on the back, this is an example of a graph that has been moved up 1. So how do you write an equation that says up 1? Well, you have your square root of x with a plus 1 on the outside. You could call it f of x or y equals or g of x. Then for the domain, remember that the domain has to do with the x's. So the smallest x value in this case is 0, and then only bigger than that, so 0 to infinity. Then the range is the smallest y value, which in this case looks like 1, and then it gets bigger, so 1 to infinity. So exactly as I've done number 1 there, you're going to try in a second to do 2, 3, and 4. Then take a look at the next set. So for the next set here, you have 4 examples of the cube root function. Again, you're going to write an equation using transformations. The domain and range is always going to be all real numbers, so I'm not making you write it every single time, although you certainly could if you want to. Again, assume that there is no stretch or shrink, and again, the first one is done for you. So if you're talking about writing an equation here in number 5, you again want to identify where that point is that connects the two different pieces, and hopefully you would agree that it's right there at 2, 0. Compared to the original parent function, which again was on the backside, I think you could see that this is right 2. So how do you take an equation and make it go right 2? Well, you have to call it y equals or f of x or g of x equals. And if you want it to go 2 to the right, it has to happen inside and it has to be the opposite, which is why you have the cube root of x minus 2 on the inside. So I'm going to go ahead now and ask you to pause and try it. So if you're watching it by yourself, hit pause, try to see if you can do the entire front side. And if you're watching it with your teacher, hopefully they will pause it for you. And then after you've had a little bit of time to practice, you'll come back and all the answers will be there. All right, so now that you've had a chance to pause and try it, let's see how you did. Here in number 2, because of the fact that the endpoint moved to the point -2, -3, that's how you know that you had to go left 2 and down 3, which makes your equation the square root of x plus 2 inside and a -3 outside. By moving to the left, the domain is now -2 to infinity, and by moving down, the range is now -3 to infinity. Over here in number 3, if you look at that endpoint, it's down 2, which is why you have a big -2 in your equation. There was no change in the domain. It's still 0 to infinity, but because you moved down 2, it's now -2 to infinity. Again, you're always going to parenthesize your infinities and bracket your numbers. And then finally, number 4, because of the fact that the graph moved 4 to the right, that's why you have that x minus 4 inside. And then because there was a reflection over the x-axis, that is why there's a negative on the outside. The domain is 4 to infinity. The range, be very careful, because of the fact that 0 is not the lowest value, but instead the highest value, you have to start at the lowest value, which is -infinity, and then 0 would be your highest value, which is why you have to put it on the right. Remember, your interval notation always has to have the smaller value on the left and the larger value on the right. It doesn't make sense otherwise. When it comes to the next set, remember I didn't ask for domain and range because it's always all real numbers, so you could write it if you want, but not necessary. Here in number 6, again, if you focus on that point where the two pieces meet, it went 3 to the left, which is why this is the cube root of x plus 3 on the inside. And then for the last two, things got a little bit interesting. If you were wondering, could there be more than one answer? The answer is yes. If you take a look at number 7, the only change that occurred from the original, and again, just as a quick visual, the original looks like this. Well, what if you reflected it over the x-axis? If you reflected it over the x-axis, then this is the equation you would have with the negative on the outside. But what if you reflected it over the y-axis? The graph would look exactly the same, which means your negative could have been on the inside. So it turns out that either of those would be correct. There's no possible way to know just by looking at it whether it went over the x or over the y, so both answers would be acceptable. Similar scenario in number 8. It clearly had to go 1 to the left, so there has to be an x plus 1 on the inside. But then if you consider reflecting it over the x-axis, that is how you would get this version on the top, whereas if you were considering it over the y-axis, you would get this version on the bottom. Just a little point here, when you have an option like this, it generally is easier to consider it as an x-axis reflection because the negative is on the outside and it's far away from the x plus 1. If you're going to write it as a y-axis reflection, you have to put the x plus 1 in parentheses to make it clear that they're two separate transformations. So in a case like this, where there's more than one thing happening, it generally is easier to think of it as an x-axis. But again, both of them would be correct as long as your y-axis version looks just like my blue version. So lots of practice up to this point with domain and range and equations. So if you're still struggling, you should reach out to your teacher. And now, if we're going to dig a little deeper, go ahead and take a look here at the backside. We've already gone ahead and set ourselves up for success on the top here by reminding ourselves of both the parent functions, their domain and range, and those table of values. What we're going to do now is we're going to try to graph these by hand using transformations. Then we're going to go ahead and find the domain and range. Again, remember, at the end of the day, you could put these in a graphing calculator and it would certainly show you the picture. But it's important that you understand the concept behind it, especially for future years where you might not have access to one. So take a look here at number 1. The first thing you want to notice is that number 1 is a square root function. Whenever you're talking about a square root function, you know that you're going to be using this table here up on the left. Whenever you're talking about a cube root function, you know you're going to be talking about the table on the right. So I tried to set it up in the same fashion so there'd be no confusion. So here in number 1, the first thing that I would suggest doing is describing the transformation in words. So because of the fact that there is a plus 5 inside of the square root, that's how you know that this is going to be a transformation of left 5. So what is it that you're moving left 5? You are moving every single thing from your parent function table exactly 5 units to the left. So that means instead of graphing x, you're going to be graphing x minus 5, comma y. And again, this x minus 5 is in relation to this x. Notice that because there are no other changes, whatever this y value is, the entire y value table is going to stay exactly the same. So in order to figure out where the new points of the parent function are going to be, you're going to take every x value from the original table, and you are going to literally subtract 5. So 0 minus 5 gives you negative 5. 1 minus 5 gives you negative 4. 4 minus 5 gives you negative 1, and 9 minus 5 gives you 4. So again, because you're going left 5, by subtracting 5 from every x, you're literally moving every point left 5. There's no changes to the y. So the y values from above, those are going to stay exactly the same in the exact same order. You're now going to take those 4 new ordered pairs and you're going to go ahead and make me a graph. Spoiler alert, compared to the original, it should have moved left 5. So if you go ahead and graph negative 5, 0, negative 4, 1, negative 1, 2, and 4, 3. If you go ahead and connect those, you'll see that it should look identical to the original function, except for the fact that it is now moved 5 to the left. Once you go ahead and have your brand new graph, go ahead and find for me the brand new domain. So because you moved 5 to the left, you moved your domain 5 to the left. So your domain is going to be negative 5 to infinity. Your range did not change because there was no up or down movement. So your range is still going to be 0 to infinity. So this is how we would teach you in a normal school year, but it's even easier for you now because you have access to your notes. So you have no excuse for not having the right ordered pairs because you can literally just look at them. Here for number 2, again, just notice that this is a cubic. So I have to use the cubic table from above. So again, my advice would be to start by describing the transformations in words. So if I'm going to describe the transformations in words, then I'm going to go ahead and say up 3. Well, how would you take a table of values and make everything go up 3? Well, there would be no changes to the x, but there would be a change to the y, and that would be that you're adding every y value, you're going to add 3 to it. So again, go back to your parent function table, which is above. Everything from the x column is going to stay exactly the same. So you're going to continue to have negative 8, negative 1, 0, 1, and 8. But then for everything that's in the y column, you're going to have to add 3 to it. So if you go ahead and add 3 to all those values, negative 2 plus 3 is 1, negative 1 plus 3 is 2, 0 plus 3 is 3, 4, and 5. Go ahead and graph those ordered pairs. So negative 8, 1, negative 1, 2, 0, 3, 1, 4, and 8, 5. Go ahead and connect the dots. Again, you should still have your 2 pieces, one that scoops up and to the right and one that scoops down and to the left. Remember that 0, 0 point moved to be 0, 3. So just like expected, the entire graph did move up 3. And again, for domain and range, these should be your favorite types of questions because they're always going to be all real numbers, at least when it comes to the cubic. 2 more should hopefully do it for you. And so take a look here at number 3. So in number 3, there are 2 different transformations that are happening. This on the outside, this is a reflection over the x, whereas the x minus 3 on the inside means that you're going right 3. So for this particular case here, you're actually changing the x and the y. So you're going to have to change both of them. In order for you to go 3 to the right, that means you're changing the x's. How are you changing them? Well, you're adding 3 to each of these. So if you go back to your original table, again, we're back to the square root table. You're going to take each of these x's and you're going to add 3 to it. So my new x column starts with a 3, a 4, a 7, and a 12. If you're reflecting something over the x-axis, you're changing its sign. If it's positive, it becomes negative, and if it's negative, it becomes positive. So how do you say change the sign? Well, whatever the y value is, you're going to make it negative. So here in the green column, you're going to go back to your original table. You're going to take anything from the y column, and you're going to switch the sign. So if you switch the sign of 0, still 0, -1, -2, and -3. If you go ahead and graph those points, 3, 0, 4, -1, 7, -2, and 12, -3, which obviously you have to kind of just estimate a tad. If you go ahead and connect those, again, a way that you can kind of guarantee you're doing it right, well, did it follow the rules that you said? You said that the graph should move right 3. Remember, the graph usually looks like this. So did your graph move right 3? Well, sure. It should be reflected over the x-axis, which means upside down. Yeah, it did that too. So that's really kind of how you'll know whether you're doing it correctly or not. And then again, for domain and range, make sure you're looking at the right picture. So for the domain, your first x value is 3. So you're going to go ahead and say that the domain is 3 to infinity. When it comes to the range, 0 is actually not the smallest value, but it's the highest. So if 0 is the highest, that means the lowest is negative infinity, and your range should look like such. One final example here, and again, notice we are back to the cube root. So back to the cube root, that just means make sure you're using the right table. This is as hard as it gets because there are multiple transformations. You have to make sure you're doing them to the right values and in the right order. So here, we're going to go ahead first, and again, in words, this is a vertical shrink of a half compared to the negative on the inside, which is a y-axis reflection, and then a down 4. So in order to determine what your new table is going to be, the first thing you have to determine is it an X change or a Y change? And if you forget, go back to your notes from the previous lesson, and it says it right there. When it comes to the Y-axis reflection, that is going to change your x's. So think about what a y-axis reflection means. Something on the right side flips over to the negative side. So you're changing the x's. So that means that from your original table, whatever the original x is, you're going to change the sign and make it the opposite. So this is going to be negative x. Then when it comes to the 1/2 and the -4, those are both y changes. Order of operations, you're always going to do your y changes, multiplication, and then addition and subtraction. So that means you're going to shrink all your y's by 1/2, and then you're going to subtract 4. So do them one column at a time. Here for the x's, you're going to go above to your x column, and you're going to take all those values, and you are going to swap their sign. So they're now going to go in the opposite order. So it's going to start with 8, 1, 0, -1, and -8. So to find your new y values, you're going to go all the way back to the parent function. You're going to take these y values, you're going to take half of it, and then you're going to subtract 4. So if I start with that -2, half of it is -1 minus 4 is -5. Half of 1 is a half minus 4, or sorry, -1. So half of -1 is -1/2, minus 4 is -4.5. Half of 0 is 0, minus 4 is -4. Half of 1 is a half, minus 4 is -3.5. And half of 2 is 1, 1 minus 4 is -3. And again, I'm getting these from all the way up at the top of the page. I'm taking each of those original y values, taking half of it, and then subtracting 4. You'll know right away from the graph, if all the points make sense, you'll know whether or not you did it correctly. So -8, -3, 0, -4, +8, -5, and then 1, -4.5, and -1, -3.5. If you go ahead and connect those, think about what was supposed to happen. It was supposed to be a vertical shrink, which means a little bit shorter. It was supposed to be a y-axis reflection, which means it should, instead of going all the way to the left and then all the way to the right, it now does the opposite. And it should be down 4. So as long as everything you told me in words should happened, then you're in good shape. And again, domain and range, these are your favorite types of questions because it's always going to be all real numbers. So that's the end of section 5.3. At this point, you should have a working knowledge of what the square root and cube root look like, all the different transformations and their domain and range. So thanks very much for tuning in, guys, and we will catch you next time.